We have Russ King joining us. As you can see on the screen right here, Russ has prepared a presentation on completing load calculations, specifically manual J, S, and D. And he'll run through that. We're certainly open for questions. Also, while Russ is presenting and prior to some Q&A afterwards, if there is anybody on the call that would like to ask questions about the program generally, or if you have you know, questions specific to your submitted claims, feel free to throw those in the chat. Or as always, you can email us at qualityhvac@frontierenergy.com and we will get back to you that way. So with that, welcome Russ, and I will pass it to you.
Awesome. Thanks, Connor. Appreciate it. It's nice to be here. Thank you for everyone for taking some time out of your day. I was asked to put together a brief presentation about the ACCA manuals, specifically manual J, S, and D. And we'll talk a little bit more about what those are, but it's kind of hard to squeeze it all into 15 minutes, but we'll we'll do the best we can. Happy to answer any questions along the way that you might have. And so Riley, if you can go to the next slide, please. So basically, we'll talk about what the manuals are, kind of how they came to be and why they're so important. And then we'll talk about how they're used by going through the HVAC design process. Okay. When you're designing an HVAC systems, there are four basic steps. The first thing you need to do is collect all the information you can about the house. All right. Then you got to get that information into a software program. So that software program can do room by room load calculations for you. Back in the day when I first started doing it, there was no software. It was all by hand. It was worksheets. You had to fill out the worksheets and you had to keep track of every wall by room, every ceiling by room, every window by room. And it was very, very tedious. And the first software came out in the early 90s and we were ecstatic. We were like, oh, thank gosh, there's software that'll help us do all this now. Because our boss just loved to, we'd do a load calculation and he'd come back and he goes, now try it with better windows. We'd had to redo the whole thing by hand. It was terrible. But with the software, it makes it much easier. And software has come a long ways just in the past few years. And I'll give you some examples of that. But not just software, but technology and the way we collect information about the house in the field has really come a long way. So if anyone out there watching, listening, is an HVAC contractor pondering doing load calculations and haven't done it in a while, things have changed a lot. Things have gotten a lot better than they had, just 5 or 6 years ago. So once you do your load calculations, then you use that to select your equipment. By the way, load calculations is manual J. Then you use that to select your equipment. Okay. It's very important that you know what the house needs. That's what the load calculations tell you, what the house needs. You cannot properly size equipment for a house unless you know what the house needs. All right. There's it's not a tiny band, but there's a narrow band above and below the load calculations, that if you're outside that band, you're too big. And if you're outside the band on the other side, you're too small. And both of those can cause issues. Most contractors, and it's human nature, just want to oversize. They just want to, they guess, they think bigger is better. They think bigger is safer. And I have tons and tons of data that proves otherwise. Okay. There's a lot of very important reasons not to oversize equipment. All right. So if you don't know what the house needs, how do you know whether you're oversized or undersized? Okay. So you've got to do that first. And then you select your equipment based on those load calculations. And then assuming it's a ducted system, you need to design the ducts. And airflow is super, super important, especially for heat pumps. Okay. Next slide, please. And next slide, please. So ACCA, ACCA, Air Conditioning Contractors of America. It's the largest HVAC trade association in the United States. They They have a huge conference every year that I go to. Um, but they started writing these manuals for doing design because the only real way to do load calculations was using the ASHRAE Handbook of Fundamentals. And that's basically a math book. All right. It just says how to calculate heat transfer across the surface, but to apply that to a house, ACCA went the next step and said, okay, well, let's make a formal process. How do you do that for a house? How do you do that for walls, floors, ceilings, and all that, and put it all together? And they put it all together into a nice manual, and that's called Manual J. All right. And these manuals are ANSI approved, which is very important. That means it goes through a rigorous ANSI approval process. So there's a formal public review and then public response and then a second review. And it has to go through all these steps. And then they get their ANSI stamp on their book. Okay. And that's usually very important if you want your book to be adopted as a code, like referenced in a code book or something like that. ANSI approval is super important. So all of their manuals are all their design manuals are ANSI approved. Okay, and they're pretty much widely recognized as the industry standard for residential HVAC design. If you look in the code, there's a couple other things mentioned. It says ACCA Manual JS&D or ASHRAE or SMACTA or something like that. But I would say 99% of all good HVAC designs use Manual JS&D. Okay, you can use ASHRAE. The whole mention of SMACTA is kind of silly. It's not even a load calculation manual. It actually references Manual J, an older version of Manual J. So it's kind of silly. But anyways, they're pretty much the industry standard. Next slide, please. And so as you can see, ACCA has a lot of manuals. The main three basic design manuals are Manual J for load calculations, okay, Manual S for equipment selection, that gives you that range, that band I was talking about, and then Manual D for duct design. Probably the next most common manual used would be Manual T for terminal selections. That's how to select registers and grills and stuff like that. But they have other manuals. Manual RS is an overview, Manual H for heat pumps, Manual LLH for low load homes. And then they have a whole bunch of standards and checklists. Go to their website, acca.org, and search for QI Standard 5, for example, and it'll bring up a free PDF quality installation standard document that's people can use. QM is quality maintenance and stuff like that. So a lot of really good information there. Next slide, please. All right, next slide. So the four basic steps: collect information about the house. Okay, perform room by room load calculations. That's where you need good software. Um, then select the equipment based on those loads, and then design the distribution system. Okay, next slide. So there's three software programs out there that do all three: Manual J, Manual S, and Manual D. There's about 10 more that only do Manual J. So if you're only looking for a load calculation, there's lots of software out there that's available. Some of it's online, it's web-based, some of it's very cheap. But that tells you a load calculation. That tells you what the house needs. If you also want to be walked through the Manual S equipment selection process, but more importantly, if you have to do duct design, these are the three software programs that do those for you. RightSoft has been around forever. That was the first one that came out. I used RightSoft my entire career. I ran two mechanical engineering departments, and that's what we used, RightSoft. Elite came out later. We were very happy when Elite came out because now RightSoft has some competition, and hopefully they would make each other better. Elite turns out to be kind of a RightSoft clone. If you can use RightSoft, you can use Elite. I've taught both of those. They both work fine. But my frustration with both of those led me to, in my son, this is our software, Quick Model with energy gauge loads. We wrote a 3D version. It's written in a video game platform. It does all the same stuff as RightSoft and Elite, but whichever one you use, learn it, okay? Because When you learn a load calc software, or when you learn an HVAC design software and you're not already super familiar with manual JS&D, you're kind of learning two things at the same time. You're learning how to use a software program, and you're learning to design at the same time. And so I always recommend that you take a basic manual JS&D class. ACCA has some very good ones that's sort of software neutral, and then understand the process first, and then you'll be a lot more prepared to learn how to use the software. Okay. But again, whichever software you use, there's all of them have classes. All of them, there's no excuse not to get trained on the software. They all have readily available classes. PG&E, SoCal Edison, all the utilities sponsor really good manual JS&D training classes. Next slide, please. So before you can start using your software, you got to get the information about the house. Okay. So if you're doing new construction in California, especially, it's super easy. You've got a nice set of architectural plans, probably a PDF file or something. And then you have a very detailed set of Title 24 calculations that tells you exactly what the energy features are in the house. Between these two things right there, that's all you need to do a good, do a load calc for sure on a house. Okay. If you're going to start doing duct design, you may want to get some structural plans and stuff like that. But for new construction, that stuff is pretty readily available in at least in California. I do designs all over the country. And there's parts of the country where, I'll say, what kind of windows are you putting in? They'll be like, I don't know. As soon as we're ready to put the windows in, we'll go buy some. And they have no clue. And the energy codes are just basically non-existent. They don't know what they're putting in the house until the very last second. And so how do you do a load calc on that? So you kind of have to assume worst case, but then you don't want to oversize your equipment either. So it gets pretty tricky. We're fortunate in California that we have very detailed load calculations, or sorry, energy calculations. Next slide, please. For existing homes, which is what most of this program is, you may not have a set of plans. In fact, you very rarely have a set of plans for an existing home. And back in the day, we used to go out, and some people still do, with a tape measure. You got your 100-foot tape measure, your 25-foot tape measure, maybe even got your little fancy laser tape measures that you can use inside the house. And you have to sketch the floor plan of the house. And that is very, very tedious. I've trained dozens and dozens of people how to do this. Energy auditors, HERS raters, HVAC contractors. I've trained them how to go out to a house with a tape measure and draw a reasonably scaled set of floor plans. It's a pain in the butt. It takes a long time to do it, and it's very difficult to do easily and well if you're not used to, if you don't have any drafting background or anything like that. The good news is technology has just blown past us. We no longer ever have to go out to a house with a tape measure because of technology such as QB Casa. Okay. Um, um, we we um, we have a relationship with QB Casa, but I don't have any business interest in them. So I have no hesitation recommending them. Also, they're free to do basic floor plans. So definitely, if you do anything, if you get anything else out of this presentation, write down that thing there, QB Casa. If you put a dot between those two words, that's their website, QB.Casa. It's a phone app. You download it to your phone. You start in one room of your house, you point it at the baseboards of your house, and you walk through your entire house, pointing it at the baseboards and the walls, and you go back. And when you get back to where you started from, you stop the little video that you're doing. It's a little data collection video, and you send that off, and they send you back a floor plan of your house that looks like an architect drew it, and it's phenomenal. I do it tonight. Anyway, just download on your phone, do it to your house tonight. They guarantee a 24-hour turnaround. I usually get like 6 or 8 hours. I'll get the file back, and then you've got a floor plan of the house. Okay, and then that floor plan can be imported into a load calculation software, and then you can build the house that way. And that's how you collect the information from the house. So that's super. It makes it much more convenient than it used to. Okay, next slide, please.
Russ, can I ask a
Yes,
question about that?
absolutely.
Does it matter if there's furniture in the house?
No, you can go right past you. In fact, I tested them. I have one of the most messy offices you've ever seen in your life. Um, and I've tested on in my office, and it was perfect. And all it needs to see is it bounces a beam off the wall, so it knows where the wall is, and it bounces a beam off the floor, and it sort of extrapolates where those two meet, and that's how it draws the baseboard. Even if you can't actually see the baseboard, it's sort of extrapolating where it is, and
Wow.
so furniture doesn't matter. Make sure you walk out into your garage, even though your garage isn't conditioned, but walk out into your garage, and it will include the garage on the floor plan. And Yeah, it's phenomenal. Every person who uses it, they're just like, oh my gosh, this is crazy. um of course, they have upsells. Their target audience is realtors and appraisers and stuff like that, and so they have, for $15 you can get one that's got color and furniture and fixtures and stuff like that, but the basic floor plan is free, and that's all you really need to do a load calculation. Yeah. All right, so there are a couple of things you don't get off a floor plan, and that's things like duct leakage and infiltration. How leaky is the house? Okay. Well, it'd be great if you tested that, but actually for duct leakage, it'll be tested later on, because in California we have a rule that says if you do HVAC replacement, you have to seal the ducts as part of that work, and you have to seal it to 10%. So 10% is a reasonable number to assume in your load calculation. All right, so that's pretty straightforward. But infiltration on the house, my philosophy on that is, whether you agree or not, is we should not be sizing equipment to leaky homes. We should not be enabling bad construction practice by sizing equipment to a house that really needs to be sealed up. Okay, so when I do a load calculation, I assume average or better leakiness, even if I suspect the house is quite leaky. Okay, because you're not doing the homeowner any service by putting on a bigger piece of equipment because their house is leaky. That's, to me, that's just dumb. Honestly, that's just dumb. It's like putting a bigger engine in your car because your tires are flat, right? Put some air in the tires, fix the car before putting a bigger engine in it. Okay. And so that's just me, but the energy code will start paying attention to this. They will, require that you don't assume a really leaky house when you do a load calculations. And I think that makes perfect sense. Okay. Next slide, please. So infiltration can have substantial effect on the load calcs. For an existing house, it's a good idea to test it. It does not take very long to do a blower door test. Once you've done it a few times, I mean, I can hook up a blower door in 10 minutes and have a number. Then once you get that number, you like to walk around and kind of figure out if you can figure out where it's coming from and stuff like that. But a blower door test is not super difficult. If the leakage is really bad, and the sort of the general rule of thumb of that is if your CFM 50 number that you get from your blower door is greater than the square footage of the house, that's a really leaky house. Okay. And that's an opportunity. You should see that as an opportunity to improve the house and make the homeowners more comfortable and help their energy bills go down. Okay. Next slide, please. All right. Then, so you collected all your information about your house. Now you got to get it into the software. Okay. And you get it into the software, and then you run room by room load calculations. So now it's looking at each individual room. What is the load on that room compared to other rooms? And that's very interesting. I've seen little tiny rooms have gigantic loads, and great big rooms have very low loads. All right. It's not the square footage of the house that determines the load of a room. It's the windows. It's the direction of the windows is the main thing, especially for air conditioning. Okay. Um, and is the room completely surrounded by? I was just helping on a project where they put a 1.5 ton ductless mini split in a family room that had a load of like, I think it had like a 1500 BTU load in it because it was completely surrounded by conditioned space. The only load on that room was the ceiling, and that was pretty well insulated. And so they put this huge ductless mini split in this room that basically had no load in it. And they didn't need to do that. So, doing a load calculation is very, very important. Doing room by room load calculations is very important for distributing the air to the right place. Okay, next slide, please. So once the loads are done, now you go pick your equipment. Okay. Manual S has an oversizing limit and an undersizing limit. For cooling, you can actually undersize your air conditioner by 10%. Manual S says it is perfectly acceptable to put in an air conditioner that has 10% less capacity than what your cooling load is. All right. And the reason you're allowed to do that is because there are parts of the country where you want that air conditioner to run as much as possible in order to remove moisture. So in very humid climates, that makes more sense. In our dry climate, we don't necessarily need to worry too much about latent removal. So, and it's also kind of a tough sell to size an air conditioner under the load. But the thing you do want to be careful with is not to oversize the equipment. Don't oversize the equipment. Oversized equipment will not maintain comfort. Okay, will cost more to install, it'll cost more to run, and it'll probably fail sooner. Those are four really bad reasons to oversize equipment. Okay. Undersized equipment, even if it's really undersized, is only not going to work on the very hottest days. And it'll still work a little bit. It'll help cool the house. It may not keep it at 75 when it's 105 outside, but for the rest of the time, it's going to work fine. It's going to work great, and you're going to have lower energy bills. Okay. But I'm not suggesting that you undersize it. If you size it correctly, it will work even on those days that are above your design temperature. Okay. And that's a whole discussion unto itself. Okay. All right. Next slide, please. So gas furnaces, they're easy. They're just dumb beasts. You just hook them up, they shoot out flame and make the place hot. Okay. But that's at the expense of, safety and greenhouse gases and all that other stuff. So, heat pumps gas furnaces are pretty straightforward. Next slide, please. Don't forget that your furnace is also your air handler. So if you have air conditioning, you have to make sure that the furnace will provide enough air. Next slide, please. So for air conditioning and heat pumps, it's a lot more complicated, all right? Because a gas furnace just shoots out flame, and the only thing that affects how much heat is coming out of that flame might be altitude. So if you go up to 10,000 feet, you're not going to get as much heat out of your furnace as you are down at sea level, but that's about it. Everything else, it's just that it'll give you the heat. For air conditioning and heat pumps, it's the capacity of the equipment is very dependent upon the outside conditions. Okay. So you have to spend more time selecting your equipment, but how can you do that if you don't do your load calculations? Okay. So Manual S has oversizing and undersizing requirements that vary by, is it variable speed equipment and all that other stuff. Next slide, please. And the thing you have to be careful about is there are basically four things that'll affect the capacity of an air conditioner. And the main one is the outdoor temperature. All right. How hot it is outside will determine how much capacity that air conditioner will give you. So you have to take that into account. The amount of air blowing across the evaporator coil has a big impact on capacity. The indoor temperature that you're trying to cool it down to has a big impact. And then the indoor humidity. What's the indoor humidity? The only house I ever had a humidity problem with was actually in Las Vegas, of all places, and it was occupant created. The homeowners never used took showers all the time, had boiling water all the time, had a fish tank, had a bunch of potted plants inside their house, and they were so energy conscious that they never ran their exhaust fans, and so they were creating a humidity issue inside their own house. And it was in Las Vegas, of all places. Next slide, please. So the air blowing across the coil is important, and what affects that is good duct sizing. All right. If you don't properly size your ducts, you reduce airflow across the coil. When you reduce airflow across the coil, you reduce capacity, the ability to cool, but you also reduce efficiency. So efficiency gets less as airflow gets less. Next slide. Indoor temperature, I mentioned that. And next slide, indoor humidity. All right, next slide, please. So, as I mentioned, airflow is affected by duct size. All right. You don't want to undersize your ducts, and I see it on the return a lot. Okay. You cannot have too big of a return grill or too big of a return duct. Okay. But I see people undersize them all the time. So, oversizing air conditioners and undersizing ducts is a huge problem that we have. People don't do load calculations, so they guess big on the HVAC equipment, and that oversizes the equipment, and then they don't do good duct design and they undersize the ducts. They use rules of thumb or whatever. They say, oh, it's a bedroom, it gets a 6 inch. Oh, it's a a 3 ton, it gets an 18-inch return or something like that. And then they're not paying attention to all the resistance and all the other things that come into play. And they oversize the equipment, undersize the ducts. That's a recipe for comfort issues. Okay, next slide. So we collected information, we performed room by room load calcs, we selected the equipment. Now let's talk real quickly about designing the duct system. Next slide. So it's one of the most overlooked aspects of HVAC design and one of the biggest sources of comfort problems. Okay. I know I have data of lots and lots of homes where the one thing that fixed their comfort problems was putting in a bigger return duct or adding a return duct, basically increasing the return capacity. The return was choking off the entire system, reducing capacity, reducing efficiency, causing balancing issues, and all they had to do was put in another return duct. Okay. Sizing the ducts is also very, very simple. But you have to understand airflow, you have to understand friction rate and things like that. But if you have a good software program, it does all that stuff for you. Okay. The hardest part of designing a duct system is getting it to fit in a two-story house. That's it. If you have a one-story house, it's usually really easy. You got a nice big attic or maybe a crawl space. It's usually not that difficult to design a duct system. You may have to run around some trusses and stuff like that. But a two-story house with a furnace in the attic and you got to get ducts down to the first floor, sizing the ducts is a breeze. Figure out how much air you need to get to the first floor. That's easy. Getting those ducts to fit down there through the trusses and through the floor joists and the beams and the flush beams and the drop beams and all that other crazy stuff. That's the only really hard part. Okay, next slide. The process for properly sizing ducts is very easy as long as you have room by room load calculations. Like I said, I've seen big rooms with tiny loads and tiny rooms with giant loads. You never would have known that unless you did a good load calculation. And that's how you know to size the ducts. That's you distribute the air proportional to each room's load. So that little room with a big load would have gotten a bigger duct than that big room with a little load. Okay, next slide. This is just the friction rate worksheet that we use to calculate friction rate. If you've ever seen the ACCA worksheet, it's very similar. The friction rate is the number that you would use in a duct slide rule. Okay, you use airflow, friction rate, and that tells you duct size. Okay, next slide. And that's it. Sorry, I went a little bit over time. I apologize. But if you have any questions, I'm happy to answer them.
Awesome. Thank you so much, Russ. That was awesome. It's just because a lot of those things are areas that, in talking with contractors, that have been a point of contention or, have been, solicit a lot of questions. And so this is really great. And I think, obviously we'll share this out to anybody that's not um in attendance. But yeah, so if there are any questions, feel free to unmute and speak up. But I know Kristen, you threw a couple in the chat there, Russ. I don't know if you can see those. If not, I can read them out.
I had the chat turned on. I buried it somewhere.
I'll just say it verbally.
Mhm.
Manual J overestimates loads. We've been hearing that. What does that imply? Does that mean it's okay to undersize by a little bit, or does that mean like it'd be really, really bad to oversize? If you add some safety factors and pick the next largest system.
Yeah. Basically what that means is you don't need to add a safety margin. Is be confident with the load calculations. I hear people saying, oh, especially on the heating side, manual J will be twice what the loads are. And to that, I say BS. Every time someone says that, I just say, show me your load calculations. Load calculations that are twice what it is in reality, they didn't do the load calcs right. Okay. Now I can see if someone's saying 20, 25%, yeah, I can understand that. That manual J is too high for that. But when I hear these numbers like 60% oversized, 100% oversized, I'm like, no, I don't believe you until you show me those load calculations and let me review them. Because the part of the problem is that some of the software that's out there is it makes it very easy. There's little tiny places where you make a mistake that's going to drive your load up, and people don't realize those are there, and so that's one of the reasons that the loads are too high is because of the software. um, so do a load calculation, know that they've already made all the worst case assumptions for you. Have confidence in your load calculations and size your equipment accordingly, and look for reasons to go down a size. Don't look for reasons to go up a size. Everyone is always like, oh, oh, this window, I'm going to round up a size. And you don't need to do that. Okay. Manual J has covered all the worst case assumptions, and go from there.
And the last thing I added was that I think offline we'll ask you to help us compile a list of all the trainings to help people do this, and we'll share that with folks because
Yeah.
there are really a
Yeah.
lot of resources out there. I know we can't obviously cover it and do justice to it in a place like this, or even in the trainings that we're providing, but there are lots of trainings out there.
Yeah. And a good manual JS&D class is going to be at least 2 days. And that's just introductory. Gary Wollen's been teaching a 3-day class for years and years. I teach a 3-day class. It's three-hour sessions, so it's 9 hours total, for SoCal Edison and sometimes for PG&E. And so there's tons of free training out there. And so there's no excuse.
Yeah. Thanks.
I'll just add this, that I've been, my very first boss out of college in 1988 was Marshall Hunt. Everybody knows Marshall. He was one of the very first ACCA certified instructors in California, and I'd only been doing manual JS&D for a couple years, and he had me take over his training that he was doing for PG&E, and so I started training. I mean, I was like, how you throw a kid in the water to teach him how to swim. That's how I felt when Marshall had me start teaching his class, and so I've been teaching people to do load calculations since the early 90s, and trying to get contractors to do load calculations. And it's very, very frustrating when you teach a 3-day class, and at the end of the class, the contractor comes out and says, hey, Russ, that was a great class, but there's no way in hell I'm going to do this. It's way too complicated. I don't have the time. The software is expensive. None of my competition is doing it. But thanks, class. Thanks for the great class. We'll see you later. And that just really, really annoyed me. And we've been trying to get contractors to do load calculations for a long, long time. We've tried asking them nicely. We've tried scaring them to say, look, it's required by code. We've tried begging them. And our final attempt is to shame them into doing load calculations. I don't have one. We have a sticker that says, do you even load calc, bro? And one of the things that I say in a lot of the classes I teach is, how carpenters have a saying, and that is to measure twice and cut once, right? So you measure again, so that when you cut it, you didn't waste a piece of wood. I'm not a professional. I do a lot of woodworking, and I'm not a professional, so I'll measure once, and I sometimes end up having to cut twice. But I don't claim to be a professional. Well, what if you don't measure at all? If you're not measuring at all and your job is to size something, but you're not measuring first, can you even call yourself a professional? And my answer is no. I think it's very unprofessional to size equipment on a house without first doing a load calc. All right. So that's my attempt to shame contractors into doing what's not only required by code, but it's just common sense. It's what they should be doing. Okay. And there's a lot of opportunity out there, to downsize equipment. This problem has been going on for a long, long time. I would say the vast majority of homes in California have oversized equipment and undersized ducts. And
Mhm.
especially if you're going from a gas furnace to a heat pump, evaluate that, figure out exactly what the house needs, figure out if there's opportunity to improve the house, and then take that opportunity to put on a smaller piece of equipment. And who knows, maybe your ducts might end up being properly sized for the smaller piece of equipment than they were for the original one. So there's opportunity out there.
Uh, One more question, I think. Um, do you have any advice for how to convey in a simple way to the homeowner that I've done this load calc and it's going to benefit you for these reasons, assuming, of course, that they don't really know what a load calculation is?
Yeah. You know, I do a lot of load calcs for homeowners, but they've already been convinced of the of the importance. They come to me and ask me to do a load calc for them. And I think what they start to realize is that and it usually comes after they've talked to several HVAC contractors. You get three contractors to come out and give you bids, and they give you three different answers. That should make you wonder what's going on. And why are they giving you three different answers? And the reason is they're guessing. They're not doing a load calculation and they're guessing. Maybe one of them did, and that's the one that you should listen to. So I use the measure twice, cut once analogy with homeowners. I say, look, if they're not really looking at your house and evaluating your house, if they're just basing their assumption on the contractor who installed the original equipment, and we have no idea who that was and how long ago that was, then they're not doing a service. And now here's the other thing. I 100% believe that contractors should be paid for doing load calculation. That's not something they should do for free. But they've kind of gotten themselves in this mess a long time ago by offering free estimates. When you go out to a house and you tell a homeowner, I'm going to do a free estimate on your house, they've basically just said, well, I'm going to do all this stuff for free. And then they just evolved away from doing a load calculations, and it's gotten to a pretty serious situation. But yeah, homeowners just need to understand that they can't assume that their equipment is properly sized in their house. And the other thing too is I think a lot of homeowners don't understand how comfortable their house really could be. They've lived in a house for a long time. They've kind of got used to hot rooms and cold rooms, but they don't realize that their house could be very comfortable and for less energy. It's crazy. So yeah.
Well, awesome. Thank you so much, Russ. And that was an incredibly informative presentation, and I think we'll be sharing that out with the broader kind of quality HVAC participation list. And not to put you on the spot, Russ, but like, is it okay if we include in there like people can reach out to you if they have questions or kind of one-on-one with you or anything like
Oh,
that?
sure. Yeah, absolutely. Happy to do it.
Awesome. Cool, cool. All right. Yeah, we'll include that. Probably we'll send out an email after this meeting with the recording of this. And yeah, obviously that offer. And thank you so much, Russ. This is awesome.
My pleasure.
All right. Well, I appreciate everybody for sticking around and showing up. And thank you again, Russ. And I'll leave it there. Thank you so much.